My name is Gian-Luigi. I'm basically responsible for the R&D developments of our business line. So what we have here is actually a flow meter, which is an instrument that is intended to measure flow inside pipes. For example, it could be water, it could be oil, or it could be gas. So if you want to measure, for example, oil, or if you want to measure chemicals, you might want to use a Coriolis meter, which is another technology. If you want to measure steam, you might want to use vortex flow meters. But if you want to measure water, at the end of the story, the electromagnetic flow meter is the best option. You can do this device from a diameter of pipe of few millimeters up to 3 meters.
3 meters?
Absolutely. As a matter of fact, we are on one of the few suppliers in the world that are actually able to produce and calibrate flow meters up to 3 meters. But one of the key applications of this specific device, of our Aquamaster device, is actually the monitoring of the network, and in particular being able to detect a leak in the networks. Of course, we are facing water scarcity in the world, and each drop counts. Each drop makes the ocean. So it is extremely important that we are able to detect these small leaks, which will typically be possible if you have a very accurate device. Inside the pipe, there is actually what we call the primary of the sensor. And then on the top, we have the electronics that processes the data and communicates the data to our customer. So in principle, an electromagnetic flow meter is made of a pipe where the water flows. There are some coils, could be on the top or on the bottom, where there is a current, and this current will generate a magnetic field. So that is basically vertical in this picture, in this way. And then inside the pipe, there will be water that flows in this direction. Water is electrons for what we are talking about. And then the electrons that you have here, when they go through the magnetic field, they are subject to a force in the third dimension. And then if you put here and here some electrons, then you will collect the electrons. Said in another way, between these 2 points, when there is water flowing, a differential of potential is established that you can then measure with the electronics that is located on the top of the flow meter. So basically, the reading that we have in the electronics is proportional through a certain factor to the magnetic field that we generate here, and the velocity of the water. I mean, the principle of the electromagnetic flow meter is very basic, it's very simple. It dates back to the 50s, as a matter of fact. But you will be surprised how much research is still connected with this kind of device. But it's a lot about the processing of the data that comes from the device. And the processing of the data is now taking advantage of technologies like machine learning, for example, which, by the way, we could also embed partially in the device. Partially would be, for example, in a SCADA system or in a system outside the flow meter.
Wow, so lots of exciting things to come still.
Absolutely.